welcome to Air Academy Associates series on using SPC Excel. This video clip will introduce you to the concept of a confidence interval, more specifically a confidence interval for a population mean. But before we go to the software, I'd like to spend a few minutes talking about what a confidence interval is and why we may want to use it, and also to show you the relationship between sampling and a confidence interval. A confidence interval is closely related to the concept of sampling because it is the data from a sample that allows the software to build or generate a confidence interval. Quite simply put, sampling is the act or process of selecting a representative part of a population for the purpose of estimating the true but unknown parameters or characteristics of the whole population. So when we sample, we gather data, individual elements or data points from a population. Together they form a sample. From that sample, the software will calculate a mean, or X bar, and a standard deviation S, and those two statistics along with the sample size are going to help us estimate a population parameter such as mu, the population mean. So that's what this is all about. It's about taking sample data and estimating something about the population. To illustrate and demonstrate the concept of sampling, I'm going to use what we call a Plinko probability simulator developed by PHET Interactive Simulations at the University of Colorado Boulder. Now, you might want to go back and get this link and play with this simulator yourself after this video clip is over at some point afterwards anyway. So I'm going to click on this and introduce you to the idea of sampling by way of the Plinko probability simulating a normal distribution in this case. So I'm going to cut this down to 10 rows, and what this looks like is a series of 10 rows of pins or pegs, if you want to call them that. The first row has only one peg, the next one has two. Now the way I have this simulator set up, the underlying distribution or population from which the samples will be obtained is a normal distribution with a mean of 5. Now in real world, when we actually do the sampling and construct a confidence interval, we do not know what mu is. In this case, we do know what mu is, so we'll be able to see if the confidence interval so constructed actually captures the population mean mu. So let's go ahead and sample. What we're sampling from is an urn up here. We're going to let balls drop from the urn. They will hit this peg, the first one, and the ball will either go to the left or to the right with probability of 0.5. Then it'll hit the next peg and go to the left or to the right with a probability also of 0.5. So let's take a look at this. I'm going to turn on the sound here so you can see a ball as it drops from the urn traversing its way through this triangular maze. Now the value for that ball turned out to be a 4. And the reason it's a 4 is what is counted as the measure of that ball is the number of times it goes right. Obviously a ball, either when it hits a pin, it either goes right or left with probability of 0.5. In this case, it went right 4 times and it went left 6 times because there are 10 rows. So that's the metric or the measure that's being used here. And let's do a couple of more. With this, that was also a 4. So our average is 4. We have standard deviation is 0 because of the two data points we've collected. They both were 4s. Now, you can even hear, when you hear the sound of the ball hitting a peg, you can hear which direction it goes because there's a little bit of different sound going left or going right. Take another hear of this as you... Now that one was a 3. Now we've gotten something other than a 3, other than a 4. We have 1, 3, and 2 4s, the average which is 3.667, the standard deviation. All of your summary statistics for the sample are given right here. The stuff in blue over here, that's the population from which we're sampling. It is a known population with a population mean mu of 5. So let's do one more. Let's get to a sample size of 10. Now, that was also a 4, and that sound might be a little bit annoying, so I'm going to cut off the sound. And you know what else I'm going to do to make this sampling go a little quicker? I'm just going to show you the path that the ball goes through. You will not hear the pings now. You will only see the path that the ball goes through. So let's get another data point in our sample, and that one was also a 4. And the next one was also a 4. And the next one was a 7. And the next one was also a 4. And there you have a 5. And we're at n equals 9, and here's n equals 10. And look at that histogram. Doesn't look normal, but this is a very small sample size. So the mean of this particular sample, and we're going to restrict ourselves to samples of size 10, which is very small, but time is of the essence here. So the mean is 4.7, the standard deviation is 1.567. We may refer to this data later, but the purpose of using the simulator is to erase this data and do another sample of size 10. So let's do that very quickly. That was a 3. That was a 7, that was a 5, and we're seeing the histogram built up here, you know, the central tendency coming up. There's n equals 8, n equals 9, and n equals 10. So that histogram looks different than the previous one. The mean of that sample data is 5.3. This one happened to be over 5, and the standard deviation is 1.337 as shown right here in our sample summary statistics. So let's do one more, okay, and get 3 different samples and different sets of sample statistics. So that's a 4, that's another 4, that's a 6, that's a 3. We're at n equals 5 right now, n equals 6, n equals 7, n equals 8, n equals 9, n equals 10. Okay, so there's the histogram for this sample of 10, the mean of which is 4.9. and the standard deviation of which is 1.37. So you see that data right over here. Now the underlying population mean, I might just tell you once more, it is 5. And so we're not. Notice that the sample averages we got were 4.7, 5.3, and 4.9. None of those sample averages were the same as the population mean. So the little Plinko probability simulator allowed us to generate 3 samples fairly quickly. The first sample gave us an average of 4.7, the second sample gave us an average of 5.3, and the third sample gave us an average of 4.9. Now in actuality, we are only going to take one sample, but my reason for doing this is to show you that when we do take a sample from a population, the sample average will typically not be the same as the population mean that we're trying to estimate. So this variability here is something sometimes called sampling variation or sampling error. The variability in these different X bars or sample averages that we could possibly get is all integrated into the confidence interval calculation. So we do not have to worry about this. The confidence interval calculation takes care of that directly. So what is exactly a confidence interval? A confidence interval is a point estimate that we get from the sample, that's the sample average, plus or minus some margin of error. So a confidence interval is an interval estimate as opposed to a point estimate, and it's for estimating some unknown population parameter. In the case of this video clip, it's the population mean. It provides an estimate of uncertainty based on the sample data, but associates that degree of uncertainty with a confidence level that can be specified by the user or the practitioner. This next page shows you how the confidence interval is calculated. This is only for the interested viewer. I recommend going to the software to do this because it's much more precise and much more accurate. But there's your point estimate. That's your sample average, and your margin of error is computed from the sample standard deviation, the sample size, and some multiplier that is a function of the desired confidence level that the practitioner would like. Again, I recommend the software. So let's go to the software here and use a simple example of a sample size of 10 customer service calls where we are measuring the response times in minutes. Those are the 10 data points, the average of which is 20.9 minutes, the standard deviation of which is 5.34 minutes. So let's go to the software and see how we can get the confidence interval. Let me quickly preview the software options that we have for generating a confidence interval. There are basically two options. The first one is the summary statistics, which is obtained from the analysis diagrams on the SPC Excel main menu. If you have raw data, like a set of 10 data points, you can highlight that data, go to summary stats, and the confidence interval will be printed down here at the bottom. You will get two confidence intervals. I'm showing you only one here, a 95% confidence interval, of which the upper limit is 24.7 and the lower limit is about 17.1. That comes from our point estimate, which is the mean, plus or minus the margin of error, which turns out this construct turns into about 3.82 minutes. We add and subtract those two, that number, 3.82 from 20.9, and on the upper side we get 24.7, and the lower side we get 17. So our confidence interval consists of two limits, an upper and a lower limit, between which we are a certain level of confidence, in this case 95% confident, that the true population mean exists. A second way to get a confidence interval in SPC Excel is to go to the analysis tools, the confidence interval, and the normal. In this option, you will be asked to put in four different values: the sample size, the sample average, the sample standard deviation, and then your desired level of confidence. Now, this option is good because it'll allow you to change from 95% to 90% or any level of confidence. The first option only gives you a 95% and a 99%, which is not shown here, but you can get any level of confidence you want using this option here. But you will have to input these four values in order to get a confidence interval. So let's go to the software. In this spreadsheet, we have the customer service times that we had talked about before. The sample size is 10. The mean of that was 20.9, I believe. And the two different ways you can get the confidence interval is to go to Sigma Zone, come to the SPC Excel menu. The first one is go to Analysis Diagrams and click on Summary Stats. And we've already highlighted the data, so we click through that, and we just need the summary stats. We don't need the dot plot in order to get the confidence interval. So we just click on OK, and here is the output that you will see from Microsoft Excel's Sigma Zone SPC Excel. And here is what we have shown you before as a preview. The sample size was 10, the mean is 20.9. Obviously you get a lot of other summary statistics, but I'm referring to this right down here. Here's your 95% confidence interval. Here's your 99% confidence interval. Those are the two automatic confidence intervals that you will get. You get it there. Another way to get it is to come to sheet 1, that's our raw data, come up here to the analysis tools and go to confidence interval and go to mean or the normal, okay? And let's blow this up a little bit so you can see it. Our sample size was 10. The sample average was 20.9. The sample standard deviation was a whopping 5.34. I don't expect you to remember that. And let's say we want 95% confidence, and there is the lower and upper limit for us, just like we had in the summary stats. The summary stats, we had 17 up to 24, and in the normal confidence interval generated in this option 2, we have the same thing. Now let's go back to the little Plinko probability simulator where our sample sizes were always also 10, and the first sample we got was 4.7 average, and the standard deviation 1.567. And now a 95% confidence interval goes from 3.57 to 5.82. Do you recall what the population mean was in that simulator? It was 5. So this confidence interval captured that 5. Now this confidence intervals, we can be 95% confident of what? That the true population mean is captured within these two numbers. And we know that's the case because in our simple simulation, the population mean was 5. Now the confidence interval does not tell you if the population mean is closer to the upper limit or the lower limit. It just tells you you are a certain degree of confidence that the population mean exists somewhere between those two numbers. Let's take the second simulation result from Plinko probability. That was a 5.3, and the standard deviation was 1.337. And there again, you'll see that this confidence interval captured the value 5. And then let's take the third simulation that we did. It was also a sample size of 10. This was 4.9. This was 1.37, and we still want 95. And again, this confidence interval captured the true population mean of 5. That's what we mean. Now, a lot of people misinterpret the confidence interval as thinking, oh, 95% of the data in the population exists between 3.9 and 5.88. That would be an incorrect conclusion about a confidence interval. That is not correct. What we're estimating in a confidence interval, in this case, is a population mean. We are 95% confident that the population mean is somewhere between 3.9 and 5.88. That's what that means. So I hope this little tutorial, together with the options you have in SPC Excel for generating a confidence interval for the population mean, has been helpful. Thank you very much.